Okay, hello again. Um, in this video, I am going to cover repetitions. Okay, so we covered sequencing, conditionals, a little bit of state, the local state, and now we're going into the repetitions, which is one of the most important things that programs do. So let me go and show you this object over here. All of these guys here that look like inverted cones are related to repetitions. So I will start with this one, which is number 3, which is a simple for loop over my name. So here's what I'm going to click it, and it's going to spell my name letter by letter. So Crista space Lopes. Okay, so let's see how this is doing it. Let's go edit the script. There's a spelling script here. Again, there's a state entry block that just gets executed once when we change something, and then there's the touch start. So what this means is that when somebody touches this object, the script asks the virtual world for the name of who touched it, and it puts it in this local variable called name. And then we are going to do something like this. So a name is a sequence of characters, right? So what we're going to do is we're going to go through each character and print out each character separately, right? So we're going to traverse, just like we traversed, the numbers in memory for sorting and things like that in the computing machine. We have these the name in memory, and the name is a series of characters, right? And so we're going to traverse each of the characters and print it out. And so here's how we're going to do. And you probably can think back about how we might do that in the computing machine, by having these counters, starting in a certain location and decrementing or incrementing the counter every time. Then you test whether you are done or not. So that is sort of how we're going to do it here, but now we're going to do it in a high-level programming language. Again, we don't care about memory locations. We care about variables and variable names and what the variables mean. So here's how we're going to do. We still need a counter of some sort. We need an index. So I'm going to call it I, and this is an integer. Again, I have to tell the processor of this language what type of variable this is. So this is an integer, just a regular number. And so here's how we do repetitions in this high-level programming language. Is something that it's a syntax that you find in many high-level programming languages. It's called a for loop. Okay, it starts with the keyword for, and then it has 3 parts. Okay, the first part they all separated with semicolons. Okay, so there's one part and one semicolon, the middle part, the semicolon, and then the last part. I'm going to explain what these parts mean. So the first part is for this integer, for this number that I want to use as my sort of counter through the characters of the string. I'm going to initialize it at some position of the string. In this case, I'm going to initialize it at 0, right? So I want to print the first character first. So that's character number 0 of the string. And then the second one is a condition for continuing to repeat. So we repeat this block of lines. So we repeat what? We repeat this block of lines within these curly brackets. Okay, this is what we're going to repeat many times. When do we stop, right? That's the question. You guys also had to identify these conditions in your algorithms. You had to identify when do you stop, for example, sorting or things like that. So you need to check when do you sort, when do you stop. So that's what is going on in the middle one, is not really when do you stop, but until, under what condition do you repeat, right? And if this condition is false, then you stop. So in this case, you repeat while the index I is smaller than the length of the name, right? Because we want to traverse every single character in the name. So at most, we have to traverse, the length of the name, meaning that we're starting at index 0 until length -1. right? So it means that it's strictly less, so I is strictly less than the length of the name. That's the condition for continuing. So when this condition becomes false, then we stop repeating these blocks of code. Okay, that's the meaning of this middle part over here. Finally, the third part is the 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 step. So every time that we repeat, what do we do with our counter, with our index that we are using here for traversing this collection of things, this collection of characters? In this case, we just want to increment one, right? So we started with the I at 0, and then we go to the I at 1, and then the I at 2, I at 3, etc. We just increment one by one. There is flexibility here in this high-level language that we could say that we jump 2 or we jump 3 or whatever, but that's not what we want to do in this particular case. We want to just jump, one by one. We just want to traverse every single character. So this is what it means, that I gets I plus 1. Again, remember that the equal sign in these high-level languages, most of them, means an assignment statement. It means that it means what the left arrow in our pseudocode meant. It means that I gets I plus 1. That's what this means. And so that's the meaning of these three parts. And so while this is true, what do we repeat? We repeat the lines within this block of code enclosed in these curly brackets. And in this case, what we're going to print out is the character at that particular index, right? Which is the index I, starting at index I and ending at index I, which is just one character at that particular position. This is how the virtual world lets us get at particular positions in a string. Okay, so this is how we are doing. It's a for loop. We're traversing the string with this idea, things that you probably already knew that you kind of need whenever you are doing some sort of repetition. You need some sort of a counter, right? So these high-level languages give you that mechanism to define names for these counters, to have very nice structure for for saying what when do you repeat, when do you keep repeating, for saying what else, at the end of each repetition, what do you want to do with the counter, right? Increment, decrement, by how much, and then finally the lines of code that we, that block of lines of code that we want to repeat many times. Okay, so let me just click on this object again, just to refresh your memory. This one traverses through the name of the person who clicked the object and spells each letter one by one with a for loop. Okay, so I'm going to go to the next one. This one is a so 04. Try to remember what it says. If I click it, okay, it's going to just spell out the song of 99 bottles of beer, all the way from 99 to 0 bottles of beer. It just keeps selling, 99 bottles of beer on the wall, 99 bottles of beer, take one down, pass it around, 98 bottles of beer on the wall, and then it starts with 98 and goes to 97, etc. Okay, so we clearly have also some sort of a decrement situation, a repetition. We want to repeat something many, many times, actually from 99 all the way down to 0, right? So we also need some sort of a loop. Now let me add it. And this is how it looks like. So let's go straight here to the touch start block. This one, I'm using what's called a do while loop. All right, so this is also a looping construct, but instead of having that three clause format that we saw in the for loop, it's a little bit more flexible. It's meant to be used for, we want to do something while something is true, and it may or may not have a counter. It depends on many things. So if in this particular case, here's what we're going to do. We start with n equals 99, number of bottles, right? We have 99 bottles. And then we say the first line of the song, which is n. And by the way, whenever we print out a number, if n, this variable n is an integer, it's a number, it's not a string. So to print it out, we need to do this thing, open paren, string, close paren. This is called a cast. we have to say, okay, this is an integer, but now I'm going to print it, but I want to print it as a string, okay? So just transform it as a string, to convert it to a string, and you say string. So we're printing 99 bottles of beer on the wall, and then 99 bottles of beer. That's the first verse. And then we're going to decrement n. Okay, so we're going immediately to decrement n. Again, remember the single equal sign is an assignment, means the left arrow. So n gets n minus 1. So now n is 98. So when we print with the second verse, n is already 98. So we say take one down, pass it around, 98 bottles of beer on the wall, right? That's what we want to, that's the right thing. And then, so then we repeat this many times. This is what it means. You repeat this block of code, okay, within these curly brackets. We repeat it many times. So while until when do we repeat, right? So we keep repeating while, in this case, while n is greater than 0. So if we get n equals 0, then we don't repeat it anymore, right? We get to 0 when we stop. Okay, so we say do these blocks of code while n is greater than 0. So it means that it does it once, it starts with 99, it does it once, and then it checks, is it greater than 0? Yes, 98 is greater than 0. Then do it again, right? Then it's 98 and then 97. Is it greater than 0? Yes. Then, so it keeps repeating this until finally n gets to 0, and then it stops, it gets out of here, okay? So that's the do while loop, which is another form of loop that lots of high-level programming languages offer. And so let me just click it again to make sure that we know. Okay, do while loops and for loops are related, and typically you can convert one into the other. So there's ways that you can convert one into the other. It's relatively easy to just, when you use one and the other, it depends, okay? So typically you want to use a for loop when you know exactly how many repetitions you want to do, and that there is indeed the notion of a counter that is counting down or counting up. So that's when you want to do a for loop. The do while loops are a little bit more flexible because the condition of the while is not necessarily, I had, for example, right now I had some sort of the number of bottles, but I could have some other condition that was not related to the number of bottles, right? I could have something else. And so it's a little bit more flexible about when to stop or when to continue. So this object over here, the number 5, so this was number 4. The number 5 does the same thing as the 99 bottles of beer, but does it with a for loop. So if I click it, it's exactly the same thing. It's just written in a different way. So let me edit it. So you can study this by yourselves if you want, but this is basically doing the same thing, but with a for loop. All right, it's a little bit more cumbersome now because of this very strict way that we have to say that the stepping, the decrement of the counter is right here, right? So it means that in between the first verse and the second verse, when we actually needed to decrement, we can't decrement. We can print the number down from it by printing counter -1. But this is not setting the counter to counter -1. It's just printing the counter -1. So just you can study what is going on in here. Okay, so let me move on to the next one. This one is a nested for loop. Let me show you what it does. If I click it, it just prints out the pattern, and with some asterisks. And so let me show you what this is doing here. Pattern. And I'm actually going to increase this pattern right here to 12. I don't know which one. I'm not entirely sure that this is actually included in your pink object. I may have forgotten to include this one. So let me go here, change this to 12 and 11, and so notice that I have saved it, and the process of saving compiles the program, and that if everything is, if the syntax is all correct, then we can actually run the script. So let me run it, and with a bigger pattern over here. All right, so let me show you what this does. This one has two loops. One is from 0. It has two nested loops. So this one has a for loop that goes from 1 to 12. Those are the 12 lines. If you count here, these are the 12 lines: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these lines up to here, these are 12 lines. So this is where the 12 comes from 0 to less than 12. Here we're going to accumulate the stars in the string. So we start with an empty string, and now we're going to put put stars in this empty string. And so how many stars do we put? It depends on the I, right? So if the I is 0, we just put 1 star, right? That's the 1 star. If the I if the I is 1, we put 2 stars. If I is 2, we put 3 stars. So now it depends on the I. So the condition of this nested loop, as you can see, this is called nested loop because you have one loop, and then you have an inside loop, something that's inside this. This is the inner loop, and that is the outer loop. So the outer loop counts the lines, right? The inner loop counts the stars. All right, that's the idea. So the stars go from 0 to I, right? Less or equal than I. So now it depends on the value of I. So when I is 0, then this is only executed once. When I is 1, then the J goes from 0 to 1. It's 2 times. When I is, for example, 4, the J goes from 0 to 4. So 5 times. Right, so this is how we are able to increase the number of stars in each line. And then once we have the stars string, we print it out, right? And then we do the opposite. We start from 11 down to 0, and we print, the pattern in the opposite direction. Okay. So just to give you an example of nested for loops. Okay, so the next one it's going to print out some table like this. So it gives you the multiplication table of the number 12. All right, again, this is done with a for loop with a repetition. Very simple for loop. When we touch it, we declare the integer I. We go from 0 to 12, including 12, and we go 1 by 1. So incremental is 1, and then we just print out the string, 12 times, and then the I, and then the equal sign, and then the result. So how do we multiply in this world? This is very common to all the programming languages. We multiply by using the asterisk sign. So 12 times I, right? It's the I starts at 0, then this is 0, then it's 1, then this is 12, then it's 2, then it's 24, etc. So we repeat this line many times. How many times? Well, from 0 to 12, including 12, right? And that's how we are capable of printing that multiplication table. Okay, so all right, so I wanted just to stress go back to the notion of state and variables, and in particular I want to show you the one where this is more noticeable is here in the do while loop. I mentioned, we've declared variables. For example, here we declare the n, it starts at 99, and here in this line we're actually changing the value, just like we did for many of our functions in the computing machine. We were changing the value in certain locations, right? Like the current maximum or something like that, or the count or something like that. So again, this is an update, right? We're updating the value of n with the n minus 1. So at that particular location now it's going to have a different value now that it's the decrement of what it was there before. Right? So that's the reason why these states here given by names are called variables, because they may vary as the program executes. Okay? So this is it. This will be enough for you guys to do the quiz. You can use these scripted objects while you are doing the quiz. That's perfectly fine. And I will explain a little bit more detail and explaining the parallels between this high-level programming language and the low-level computing machine on Thursday. Goodbye.